programming tutorial. Today we are going to the number 3, talking about the numbers in Lua. Actually, in any kind of the programming language, the numbers or data types are the normal parts we should understand in the first place. However, the Lua has some special treatment about the numbers, and you will learn there's also kind of the version difference between their treatment on numbers, especially the integer and float. So let's start with that. So first of all, in the GitHub, I have updated so the program of the sample code for this book. I will put into this program in Lua, which is based on the 4th edition. And I show you the book online during this exercise, but gradually all the sample code will be putting into the specific chapter folder. Like last video, we discussed about the 8 cream puzzle. And this code is already here, and you can come to this and download, and or you can fork this repository that you have this source code. I hope those can save some of your time. And then if you come to the README in the front, I'm starting to list down the video link, or you can come to my YouTube channel to get all the other videos. So we already have 3 videos so far. So this is the number 4, and we're based on this chapter 3. Just for also your easy to have is if you come to here, so Lua. In the days here is the add this one. So I think it's which one is the last one? I suppose. Yeah, the second from bottom. This is the Roblox game programming, the complete mind map, which I'm going to keep updating. And sorry, I got some code, so excuse me for those. For every chapter, I will give you the detail of this structure. And for today, these numbers, actually there's about 7 sub-chapters. So talking from the specific number rows, then go to the operator, different operator, arithmetic, relational, and then we talk about a few of the famous mathematical library to deal with the different samples. And we have the max integer, minimum integer to show in the representation limits. That is an interesting part from Lua. And then we're talking about the conversion. The last but not least is same as all the other language. If you processing the mathematical the way, you need to know the precedence of the orders, which is calculate first, which calculate second. So those are overall will be the kind of the sequence of the token numbers. After that is next video we come to the string and then go to the table. So because there's a lot of the direct practice, not coding, so we will use just the command window to practice that. So if you come to here, let's just type Lua. You can go to here. My Lua is 5.4.2. So you get this prompt. And before we go to the detailed text, I would like that you can get some quick the tip about how to manage this command prompt. So there's a saying is if you want to learn how to ride a bicycle, you need to learn first how to exit, how to stop the bicycle, how to make you get off from the bicycle. So know how you can exist and how you can clear the screen will be the important when you start to use this command. So first is I introduce this echo. So that's starting from the OS library. Then you use this execute some command. So you remember is have this the com, putting them in the those. So hello world. Then if you enter, sorry, there's nothing because I have wrong this one. So you need to distinguish this string. Undefined string near. Yeah, you can see you need to have our space like this. Then through this way, you can get some echo. It's not just used for print or hello world. This echo, the most useful is for the debug. So if you are doing something in the middle, you want to get some the value want to show, you just use this echo. So if I put this a price equal to 5, a is here. So it's not recognize internal the command. So that is you cannot simply make this the export. So that is the thing is difference as if you have a variable, you are not able to in this prompt to echo that. But that is press just one echo, and if you have a lot of the command here, you want to make a clear. So it's not simple like you cannot do this clear, you cannot do this CLS, but actually you need to call this OS library. So remember this, you come to the os.execute and clear is a command. So actually you put our command inside this OS execute, then you can get a clean screen. And that is the in my Windows, you can. I also use clear is okay, but in the book they mentioned is Windows you can use CLS, Unix you use clear, but you can just take your try. But remember this, if you have a too busy screen, use that to make the screen clear. The last I want to mention is that this OS exit. So you can use this to quit from the command. So and you can use lure and you see. So you can use Ctrl Z as well. So. That is the same as this OS exit command. So you can try to use both. Okay, if you have that part, so let's see. So I want to use OS execute CLS. Oh, so exe. It's because I'm not in Lua now. You can see CLS. Then I get this a little faster than here. So maybe because it's a Windows 11, I suppose it's called the Linux subsystem. Then let's go to the Unix command and read the interpreted by the Windows command window. But if you use this CLS, that will be better. So we come to the numeral. So write those numerals. If you write a 4, you get just a 4. 0, 4 is this 4. let's just keep practice. So when I write this in the scientific mathematical way, so it gave me the real this float number. If I put this tens of this 12 times, so that's give a very big one, and 5e, but they don't show you too big. So 5e or 3e is the same. So if too high, too big, they will not show you. Like is you can test. So what 13 they can show you, but 14 they starting to show just in this scientific way. So that's just our this display, and we can use this type to know the actual type of this number. But if you see no matter integer or float, the type is just our number. So this is the way, because within the Lua by default they just make our number as the cover both integer and float. And if you they also have the balloon, but we skip this first. You can see here we use a mass library. So this is not the default type, is the type within the mass. So if I put this from the mathematical way, this 3 is an integer, and from the mathematical way, this 3.5 is a float. So that can be used to distinguish the type of the two different numbers. But if you don't use the mass library, it just tell you they are numbers. So they don't distinguish that from the normal way. And the Boolean is if I see whether 1 is equal to 1.0, so that is same as here. So because from the Lua they treat both of them are number, so they are same. So same is if minus 3 is whether is equal to minus 3.0, is true, and even 0.2 through this time of 3 times power of the 3 times. This is the 200, and the 200.0 is equal to 200. So that is the true, and this also true. So that is, and one more thing is 3 equal to 3, 3.0 equal to 3.0. So they show them differently, but in the internal, the system, they treat them as the same value. So that is the one first thing when you come to the number is you need to understand is not exactly the same like other language. And also, we can also have this the hexadecimal constant. So, but you need to same as the starting from this 0x. So that's F5 is represented in the decimal is the 255. So 0x 1 is 3. So that is 419. 0x even is you can have this in this the float or the decimal. You can see that is 2 is 1/3 or 1/8 of 16. So that is the 1/8 of the 10 will be the 0.125. So that is the calculation behind 1p and 0x a dot b p2. A is actually is the 11, B is the 12, or A is 10, B is 11. And we can write number in this format, use this percentage %A. So let's try this format, use percentage %A 419. Then I can write this in this hexadecimal the format. So if I put that 0.1, you can see like here, let me see here, is 4275 respect to this the 1.56 power 5. And then let's use OS execute CLS. Now we get this one. And we are trying to do this operator. We can do this fast because just plus, minus, times this divided is the same as other language. Just let's do this divide. So 3.0 divided by 2.0 will get our 1.5. So float divided by float will be our float. And the 3 is integer divided by 2 will be 1.5 as well. But we can use this float division, or we call this the integer division. So if I use this, then I only got 1. And I use this. Because both, if that is the float, you will get our float result as well. You need to have that both are the integer, so you can compare to this. And then we have this the modulo, the operator. So like it's 5 times mode 2 will be 1, so it's the dividend result will be 2 and the remainder is 1. So that's the same. And we also have the such kind of some library for the constant mass.pi, give you just the direct pi. And then we can use mass.pi minus mass.pi get mode. Then I removed all the rest of the part, and then this I just have this 3 digit after the dot. And another example for modular is if we want to check whether our vehicle turning a given angle will start to backtrack. If the angle is in degree, we can use the following format: local tolerance. This we can use our chapter 3. So let's add our part is vehicle turning. Local is a local the variance. This you give that tolerance are 10. So you can see here. Let me make the extension. Even they have already detected the syntax, but if you don't have this lure, you cannot run that. So we define our function is turn back angle is auto indent angle equal to angle mode return mass ABS print is turn back. Angle is minus this. Let's run that. You can see get true. If I see I want to see 270, false. Let's see here 90. You get false. So only is when it is turned or given the angle, you will get that because your mass is angle minus 180 to compare with 10. So that is if I see the angle is 190 or 190, then that will be the 10, and then this will be, let's see, 156. 1585. That will be true because that's within this angle. So that is the thing is if you have something you want to make a comparison, they give you our mode is just over 360, and they just find this modulo. So that is our sample program. I put that here, and also if we want to work with radius instead of degree, so we can also put that based on the mass pack. So that is another part is we can base on the length, not this degree. So I don't make this separately. And very simple for the relational is the less, more than, less than equal, more than equal. So you can have this. So I parallelly I'm preparing the Fortran this video. This native language like Lua is just use this operator, but in some old language like Fortran, you also have something like. If you want to see the LE less and equal, in Fortran you can also use something like this. That is same as this one. So just compared to the different language, you just need to learn what's the specific in your language. And some of the library, so I put this roughly is here. We have we will talking the random, the number, and also the round number, the function. So let's stop here first and continue for the next video to close finish these numbers. Thank you.